You're going to start the next one, amines. In amine, you are having 1 degree amine, 2 degree amine, 3 degree amine. This is an example for 1 degree amine, methylamine, like this. General formula RNH2. It should have 1 alkyl groups, maybe big or small. Here you should have 2 R with 1 H. For example, dimethylamine. Tertiary means 3 R. It can be same or mixed. That depends upon the formula. They can easily cheat you in giving the 3 types of amines. How they can cheat you? They'll tell tertiary butyl amine, to which amine it belongs to. Many will tell it belongs to tertiary amine. No. Tertiary is initial. Don't go for the classification. There is only 1 alkyl group. You select this one. Since it is having 1 alkyl group, it is a 1 degree amine. I write the structure. To have more clarification, I write the structure. If somebody says secondary butylamine, that is also primary because it contains only 1 butyl group. Then which is a secondary amine? This is secondary amine. Ethyl. If somebody says ethyl methyl amine, how can you find? There's 2 groups, ethyl methyl. So it is a secondary. Somebody says dimethylamine. It is also secondary amine. See to that, you are having 2 alkyls. Somebody can ask you some twisted question. Secondary butyl methylamine. Nothing is there. How will you find it out? Sir, there is a 1 butyl group and there is a methyl group. Since it contains 2 groups, it is a secondary amine. How will you find the tertiary? See, diethyl methylamine, somebody will tell like this. Then how will you find? 2 ethyl, 1 methyl, so totally it is a tertiary amine. That's all. So, how to classify all this? By counting the number of alkyl groups. So, okay. Now, we are going to the reaction. RNO2 on reduction using tin bar HCl. Any nitro group on reduction gives primary amine. That's all. Any nitro. Don't worry about that others. Okay. Second one, ammonolysis. Since you are using ammonia as a starting compound, it is called as ammonolysis. You are writing this compound. When you treat ammonia with methyl bromide, what will happen? 1 methyl will be introduced, 1 H will be replaced, like this. Again, you can go for methyl bromide. You see, you will be getting dimethyl, like this. And again, when you treat with methyl bromide, you will get trimethyl. Then again, when you treat with methyl bromide, you are getting additive quaternary salt like this. You see, methyl is going inside, bromide is outside. You see, this is a 1 degree amine, this is a 2 degree amine, this is 3 degree amine, this is quaternary salt. This is a quaternary salt. In all this reaction, you can watch. You are having 3 hydrogen, 2 hydrogen, 1 hydrogen, no hydrogen. Slowly the hydrogen is decreasing, finally goes into quaternary salt. Next one, any cyanide on reduction is already mentioned, but again I am repeating again and again. Any cyanide on reduction gives a primary amine, that is CH2NH2. One carbon will be increased. But what will happen when you reduce isocyanide? Here you should be very, very careful. What will happen when you go for isocyanide? You see, this group will be maintained, this will be maintained, and this carbon alone, not this one, this carbon alone changes into methyl. So what will be the answer? This is the answer. Ethyl methylamine. See, when you reduce a cyanide, it gives a primary amine. When you reduce a isocyanide, it gives a secondary amine. That is the difference. Okay, next one. Any amine, when treated with nitrous acid, is very simple, you all know. It gives an alcohol. It gives a corresponding alcohol. That's all. But for phenol alone, to prepare phenol, when you start with aniline, it will not directly give hydroxy. First, it gives a diazonium salt, then on hydrolysis or warm with water, then only it gives phenol. For aniline alone, the product will not be directly obtained. It is an intermediate through benzene, diazonium chloride. And for this, it is a aliphatic. But somebody can ask me, sir, what about benzylamine? How we are going to write for benzylamine? Whether directly or indirectly. What we will say? Benzylamine means it belongs to an ordinary amine, not like aniline. So, when you treat with nitrous acid, directly it gives benzyl alcohol. No intermediate for benzylamine. No intermediate for benzylamine. Next one, amide. Next one, amide with bromine alkali or reduction using lithium aluminum hydride or tin bar HCl. You see, we are having the two cadre regarding amide. When you treat with bromine alkali, the CO will be eliminated. You see, it is eliminated. This reaction we are going to learn in the next class, which is known as Hoffman reaction. When you reduce, it changes into CH2. You see the difference. This is all very important. These reactions are very important. When you treat with bromine alkali, CO is eliminated. When you reduce, CO is converted into CH2. Okay, next class we are going to see the first level reactions of amines. We are going to start amines first level. In the previous class, you have just seen the common reactions of amines. But today we are going to see the first level, that is very important. It's like this. So, first you are going to see Gabriel thalamide synthesis. Gabriel thalamide synthesis. When they ask for this particular reaction, you should have this idea. H is converted into K by using KOH, and the K is converted into methyl, then the methyl is converted into methylamine, like this. For example, how H is converted to K? By using KOH. K into methyl means methyl iodide, and methyl is converted into amine again by KOH. Now I will write the equation. See, this is thalamide, this name, thalamide. You should start with thalamide. Then, first I told you, you treat with KOH. Then what will you expect? What will you expect? This H is converted into K. Then you treat with methyl iodide. The K will be converted into methyl. Then again, you treat with potassium hydroxide. The product is over like this, methylamine. But you want to know how you are getting this product. If you want to know means, I will tell you. See, here the bond cleavages take place like this. The reaction takes place like this. So, what will be the byproduct? This is the byproduct. COOK, COOK. That is potassium phthalate. The name is potassium phthalate. What is the name of this one? N. For this one, you can call as potassium thalamide. Here, N-methyl thalamide, because the methyl is attached to the nitrogen, so you should call as N-methyl thalamide. And this reaction is only applicable for aliphatic primary amines. It is not applicable for secondary amine, tertiary amine, aromatic amine. So this method cannot be used to prepare aniline. Okay. Next one. Next one, you are going to see Hoffman reaction. Next one, we are going to see the Hoffman reaction or Hoffman degradation. Degrade means reducing the number of carbon atom. That is called degradation. Okay. You see, you take any amide as you wish. You take any amide. Then you treat with bromine alkali. Then what will happen? The CO is removed. That is the technique. The CO is removed. So what will be the product? Methylamine. What are the other products? Don't by heart, just guess. Try to start guessing many reactions. You see, these two will combine to give potassium bromide, and this CO is converted into carbonate. The carbonate is due to the CO. Next one, as usually, water. So, okay. If you want to balance, what you have to do? 2 potassium, so 2 plus 2, 4 potassium, 4, then 4 oxygen, 4 hydrogen, then you have to write 2 here, that's all. If somebody feels difficult in writing like this, you can just concise like this. Bromine alkali. At least you try to write this also. Okay. But in some paper, this mixture is given as like this. Both are same. They give bromine alkali or NaOBr. Both comes under Hoffman degradation. This method is used to convert higher carbon to lower carbon. That is the technique followed here. So, okay. Next one. Next reaction is carbylamine reaction. Next one, you are going to see this carbylamine reaction. Third one. What is the basic concepts of carbylamine? Here, NH2 is converted into NC by using alcoholic potash chloroform. The NH2 is converted into NC. You write any NH2 compound. You write any NH2 compound. For example, methylamine, ethylamine, aniline. You can write anything. You treat with chloroform and alcoholic potash. See to that this NH2 is converted into NC. This is very important. The NH2 is converted into NC. Then what are the other product? You guess like this. Potassium chloride, water. You guess like this. So the other product are these one. Now if you want, you can balance. You see the 3 chloride. So 3. When you write 3 for chloride, potassium increases by 3. So you write 3 potassium. When potassium increases by 3, oxygen also increases by 3. Okay. What is the name of this compound? You can tell in 2 ways. That is phenyl carbylamine or phenyl isocyanide. Phenyl isocyanide. And this will have a typical foul smell. Will have a foul smell. This is applicable for all primary amines. You can write any primary amines. That is very important. Okay. Next one, we are going to see diazotation. Next one, you are going to see diazotation. You see, diazotation means, first of all, you understand what it means. Nothing, again I am telling. It is a preparation of benzene diazonium chloride. This is called as diazotation. You see, whenever you have a N2 in the middle, they name it has a diazotation or diazo group. Indirectly, it is called as a diazo group. See how it is prepared? You take aniline. You treat with sodium nitrite and HCl in the presence of 0 degree or 273 Kelvin. So the product will be benzene diazonium chloride, and these are the byproduct. That's all. What is the purpose of having this combination? This combination you are taking because to produce nitrous acid. Nitrous acid is the main component for the conversion of aniline to benzene diazonium chloride. But it cannot be stored in a bottle because it's unstable. That's why we are preparing and readily using for that reaction. Otherwise, you can write directly nitrous acid, like nitric acid. You know nitric acid, it is highly stable. But this is unstable. That's why you are writing like this. Okay. Next to reaction, Sandmeyer. We are going to see Sandmeyer reaction. Sandmeyer means you are preparing chloro and bromo compounds from benzene diazonium chloride. We have already seen this. These are repeated questions. We have already seen in haloarines. That is the first chapter. Now we will write quickly. See, like this. What is the product? Because of Cl, you write Cl. Because of bromide, you write bromide. Because of cyanide, you write cyanide. Because of chloride, I am writing a chloro compound, bromo compound, then cyano compound. Okay. Here, what is important? The selecting of the catalyst is very important, like this. The selection of the catalyst. That's all. And these are byproduct. These are byproduct. But in some schools, they'll ask some tough question. What? Benzene diazonium chloride to benzoic acid. Then, of course, I'll tell you in the benzene diazonium chloride later on. So, here we are preparing chlorobenzene, bromobenzene, iodobenzene, and these are the catalysts. Okay. Next one, Gattermann reaction. Gattermann, goat is entirely different from Gattermann. When anybody says Gattermann reaction means you should convert same reaction, but slightly you change the catalyst. That's all. When you change the catalyst, it is called as Gattermann reaction. Okay, next one you are going to see coupling reaction. Next one we are going to see coupling. When anybody says coupling reaction means, what should I think about it? This compound will be common. Benzene diazonium chloride will be common. Okay. Then how will you write? You write benzene diazonium chloride like this. Double bond is not necessary. But don't write like this. This is wrong. If you write like this means it is totally wrong. Why? Because you are not linked to the carbon. You link to the middle of the carbon. So chemically it is wrong. So for this reaction, you should write the benzene in the flat form. Flat. You should be in the flat. Okay. Next one, you treat with phenol. You see, you are treating with phenol. And this group is responsible for the color of the dye. Casually, you remove this HCl. You see this and follow the products. You see, we are having benzene ring. Okay, you write the benzene ring. N2, N2, again benzene ring. So you write again benzene ring. Then with Cl, that's all. Sorry, with OH. That's all. What is the name of this compound? Para. With related to this, it is called para. So, para hydroxy azobenzene. This group is called azo. So, the name is called as para hydroxy azobenzene. If somebody asks for aniline, aniline means you change the reactant. That's all. Instead of phenol, you write aniline like this. But here also you should change the condition. That's all. These are coupling reaction. So, okay. Next one, for coupling reaction, in both the temperature should be low. Okay. Next one, we are going to see. Next one, we are going to see Heisenberg reaction. You see the reaction with Heisenberg reaction or Heisenberg compound. So, that is a Heisenberg compound means what? Benzene, sulfonyl chloride. Okay. So, this is a reagent used for in this reaction. Okay. First, we are going to see this particular compound for this Heisenberg for primary amine. Primary mean this is ready to give chloride, so that compound will readily for giving H. That's all. You see, this is the technique you should know. Whenever you write a chloride compound means this chloride will be eliminated and it needs some hydrogen from the other compound. So, this will be the product like this SO2 HNCH3 plus HCl. Okay. What is the name of the compound? N-methyl. N-methyl benzene sulfonamide. It is called as N-methyl benzene sulfonamide. So, okay. Then, what about this one? Regarding this one, it is soluble in water, soluble in alkali. It is soluble in alkali. Second one, B, same reaction with secondary amine. So, this is primary amine. Now, I am going to write for secondary amine like this. As usually, you remove the HCl and you write the product. What is the name of the compound? N-dimethyl sulfonamide. That is N-methyl benzene sulfonide. This is N-dimethyl benzene sulfonide. It is insoluble in alkali. It is insoluble in alkali. Then what about the third one? With the tertiary amine. When you go for third one with the tertiary amine, you can say, since we don't have any hydrogen, there will be no reaction. There will be no reaction. Okay. Next one. But this Heisenberg compound is given like this in your book with all double bond and all. That is not necessary. like this, giving with all double bond. It is not necessary. You write directly. Okay, next one. Next one is ammonolysis. See, many reactions again I am repeating again, because already known to you. I'll write you like this. When ammonia is treated with methyl iodide or methyl bromide, first hydrogen will be replaced to form primary amine. See, one hydrogen is replaced by a methyl group to form a primary amine. Secondly, when you treat with again, then second hydrogen is also replaced like this. Second hydrogen is replaced. Then again, when you treat with methyl bromide, one more will be replaced. This is primary, this is secondary, this is tertiary. And when you treat with one more methyl bromide, it will give quaternary salt. It will give the quaternary salt like this. This reaction is commonly known as ammonolysis, but here we are able to prepare primary, secondary and tertiary.